Hello everyone, welcome to our new lecture. Now we are going to study about oxidation and reduction, okay, from chapter number 3, that is chemical reactions and equations. In our previous lecture we have seen the factors which affect the rate of chemical reaction, okay. Now in this lecture we are going to see another types of chemical reaction, and those are oxidation reaction and reduction reaction. So what is oxidation and what is reduction? Let us see that. So here you can see there are certain reactions which are given in the form of equation. The first reaction, which is the two molecules of Mg, okay, it is reacting with the oxygen molecule and we get the two molecules of magnesium oxide, okay. So this is the reaction between magnesium and oxygen molecule. Whereas in the second reaction, you can see the carbon is reacting with oxygen and we get CO2, that is carbon dioxide. In the third, you can see that the magnesium hydride, okay, MgH2, is decomposed in magnesium and hydrogen gas. Whereas in the fourth reaction, you can see it is ethane, okay, CH3 single bond CH3, okay, which is reducted to CH2 single bond CH2 double bond CH2 into plus H2, okay. So in the fourth reaction, ethane is decomposed, okay, to ethene and we have got hydrogen gas, okay, which is liberated out in the reaction. Now, in all these four reaction, you will see or you will observe certain thing, okay? And what we are observing that in the first reaction, oxygen is gained or oxygen is combined with the element, okay, magnesium. In the second reaction also, we can see that oxygen is combined with carbon to give us carbon dioxide, okay. In the third reaction we can see that the hydrogen is evolved out, okay, it is separated from the compound, okay. And in the fourth reaction also we can see that the hydrogen is separated from the reactant, okay. So all these are the examples of oxidation reaction, okay. All these four reactions are example of oxidation reaction, okay. So what is the definition of oxidation reaction? It is the chemical reaction in which a reactant combines with oxygen or loses hydrogen to form the product, okay, and it is called as oxidation reaction. So a reaction where you will see that the reactant is going to be combined, okay, with oxygen, or the hydrogen from the reactant is going to be eliminated, okay. So gain of oxygen or lose of hydrogen, okay, gaining of oxygen or losing of hydrogen, okay, within the reactant. Such reaction is called as oxidation reaction, okay. Now, some oxidation reactions are brought about by use of specific chemical substances. Okay, for example, in this reaction you can see ethyl alcohol. Okay, CH3CH2OH, that is C2H5OH, the molecular formula of ethanol. Okay, one of the important alcohol it is. Okay, used in lots of substances, C2H5OH. Okay, so ethyl alcohol is reacted, okay, in presence of potassium dichromate, okay, acidic potassium dichromate, and this acidic potassium dichromate is going to provide the oxygen, okay, to this reactant, okay. It is going to give one oxygen to this reactant, and we will see the formation of acetic acid, that is CH3COOH, okay. So when ethyl alcohol is introduced by the oxygen, okay, from dichromate, okay, potassium dichromate, then we get acetic acid as the product. Now in this reaction, potassium dichromate, acidic potassium dichromate is the provider of oxygen to the reactant, okay. So in that case we will say this potassium dichromate as an oxidizing agent, okay. What we will say, we will say it as an oxidizing agent or oxidant. So any compound or any chemical which is going to provide the oxygen to the reactant, okay, for oxidation reaction. So in that case, we will say that chemical substance, we will refer that chemical substance as oxidant or oxidizing agent. Okay. So here acidic potassium dichromate is my oxidant, okay, for ethyl alcohol. Now, do you know a variety of oxidants are used to bring about a controlled oxidation? Okay, so potassium dichromate or acidic potassium permanganate. Okay, this is the formula of potassium permanganate. Okay, KMnO4. So these are the commonly used chemical oxidants. Okay, whereas hydrogen peroxide is also used as an oxidant. Okay, but it is a mild oxidant. Okay, so hydrogen peroxide, that is H2O2. We can also use ozone, that is O3 molecule, okay, as a chemical oxidant. Now what all these oxidants do, they provide the nascent oxygen. Okay, they are going to provide the nascent oxygen to the reactant. Okay, thus the oxidation reaction takes place. So here also you will see certain reactions, okay, which shows us that how all these oxidants are going to provide the nascent oxygen. Okay, so ozone is going to provide one molecule of nascent oxygen. Okay, H2O2, that is hydrogen peroxide, is also going to provide one molecule of nascent oxygen. But potassium dichromate is going to provide three molecules of nascent oxygen, and potassium permanganate is going to provide five molecules of nascent oxygen. Okay, the symbol of nascent oxygen is like this. Okay, this is the symbol of nascent oxygen. Keep this in mind. Okay, so nascent oxygen is represented within the square bracket. Okay, the bracket must be a square bracket, and O is written between the square bracket. So this is about the oxidation reaction. Okay. So it is a chemical reaction in which reactant is going to combine with oxygen, or it is going to lose the hydrogen, okay, to form the product, and it is called as oxidation reaction. And the chemical which is going to help or which is going to provide the oxygen for oxidation, those chemicals are called as oxidants or oxidizing agents. Okay. Now we have seen just now that potassium permanganate is a chemical oxidant. Now have a look at the following reaction. Okay, so two molecules of potassium permanganate is reacting with 10 molecules of ferrous sulfate, okay, along with the 8 molecules of sulfuric acid. Okay, and it is going to give us potassium sulfate, that is K2SO4, plus 2 molecules of manganese sulfate, okay, that is 2MnSO4, plus 5 molecules of ferrous sulfate plus 8 molecules of water. Now, which compound is oxidized by KMnO4 in presence of acid in this reaction? Of course, FeSO4. So your KMnO4 is definitely my oxidizing agent, and it is going to oxidize the ferrous sulfate. What it is oxidizing? It is oxidizing ferrous sulfate. Okay. So here you can see on the reactant side the number of oxygen molecules or the number of oxygen atoms. Okay, how much oxygen atoms are there in this particular reactant, that is 10 molecules of ferrous sulfate? There are 40 oxygen atoms. How much? 40 oxygen atoms. Okay, 10 fours are 40. But in the product side you will see the number of oxygen atoms is 60. Okay, 4 oxygen in sulfate ion, which is multiplied by 3, so we get 12 oxygen. Okay, 12 oxygen atoms, and 12 oxygen atoms multiplied by 5, so we get in all 60 oxygen atoms in the product side. Okay, in this reactant, that is 5 molecules of ferrous sulfate. So you can see in the reactant side there were 40 oxygens atom with ferrous, but in the product side number of oxygen atom has been increased. That shows us that oxidation of ferrous sulfate has taken place. Okay, So your FeSO4 is transformed into Fe2SO4 thrice. Okay. Let us now see how this conversion is an oxidation reaction. So here you can see two molecules of ferrous sulfate, okay, is converted to ferrous Fe2SO4 thrice. Okay. So if I want to represent this reaction in the form of ionic reaction, we are going to see that Fe2 plus SO4 2 minus. Okay. It is oxidized in such a way that we get 3 plus sign over Fe, and 3 molecules of SO4 2 minus has been generated. Okay. The net change taking place in the above conversion is shown by the net ionic reaction as shown below. So what is the net change? The net change is that Fe2 plus has been converted to Fe3 plus. That means the number of ferrous atom has been reduced, but the number of electron is balanced, okay, by the donation of Fe electron. Okay, so we get Fe2 plus converted into Fe3 plus. Okay, so ferrous is converted into ferric. This net ionic reaction represents the oxidation brought about by KMnO4. When ferric ion is formed from ferrous ion, the positive charge is increased by 1 unit. Okay, while this happens, the ferrous ion loses 1 electron. So when ferrous ion is going to lose 1 electron, obviously the charge will increase over Fe. And that is why the charge is increased by 1. Okay, so we get Fe2 plus converted to Fe 3 plus. Okay, from this we understand a new definition of oxidation, and which is oxidation means losing one or more electrons. This is the most correct and precise definition of oxidation. Okay, which is like this, that oxidation is nothing but losing one or more electrons. Okay, so when the atom is going to lose one or more of its electron, then we can say that atom or the element has performed oxidation reaction. Now let us see what is a reduction reaction. So a chemical reaction in which reactants gain hydrogen are called as reduction reactions. Okay, so a reaction where you will see that reactant is going to gain the hydrogen and it is going to eliminate or lose the oxygen atom. In that case we can say that the reaction is a reduction reaction. Similarly, the reaction in which a reactant loses oxygen to form the product is also called a reduction reaction. The substances or the substance that brings about reduction is called a reductant or a reducing agent. So any reactant or any compound which is going to lead, or which will be the compound, okay, which is going to perform the reduction, okay, which is going to reduce the oxygen or provide the hydrogen, that particular compound is going to be called as reductant or reducing agent. Okay, now when hydrogen gas is passed over black copper oxide, a reddish colored layer of copper is formed. So here example of reduction reaction is given to us. So when we introduce hydrogen gas on copper oxide CuO, okay, what we are going to get? We are going to get Cu plus H2O. So here you can see that oxygen has been eliminated by the copper. Okay, thus this reaction is a reduction reaction. In this reaction, an oxygen atom goes away from CuO, that is copper oxide, which means that the reduction of copper oxide takes place, whereas hydrogen molecule takes up oxygen atom and H2O is formed, meaning oxidation of hydrogen has taken place. Thus, oxidation and reduction reactions occur simultaneously. Now, we can say if the oxygen is eliminated from the copper, that means this is the reduction, but oxygen is gained by the hydrogen. Okay, here you can see that the oxygen is gained by the hydrogen. In that case, this is oxidation. Okay, and this is the reduction. So when oxygen is loosed, it is reduction, and when oxygen is gained, it is oxidation. So in that case, this reaction is representing reduction as well as oxidation reaction. Okay, so when the reduction reaction and oxidation reaction takes place simultaneously, such type of reaction is called as redox reaction. What it is called? It is called redox reaction. So what is the definition of redox reaction? It is a reaction where you will see the oxidation and reduction in the chemical reaction simultaneously. Okay, so we can also write redox reaction is nothing but reduction plus oxidation. Okay, here two more examples of redox reaction has been given to us. Okay, two molecules of hydrogen sulfide reacts with sulfur dioxide and we get three molecule of sulfur and two molecules of water. One more reaction is given, which is manganese oxide is reacted with four molecules of hydrochloric acid and we get manganese chloride, two molecules of water, and we also get the liberation of chlorine gas. Okay, both this reaction are example of oxidation and reduction reaction. Okay, so this is about the redox reaction, reduction reaction, and oxidation reaction, which we have studied in this particular lecture. Okay, now we will study about the corrosion in the next part or in the next lecture. Okay, also we will see what is rancidity. So this is it for today's lecture. We will meet in the next lecture. Until then, goodbye.